Assalamu alaikum students. Okay, today over here our topic is Theorem 3 from chapter number 12, and the object over here is if a transversal intersect two coplanar lines such that the pair of alternate angles so formed are congruent, then the lines are parallel. Okay, what do we have over here? They're saying that there's a transversal which is going to cut two coplanar lines. If it cuts two coplanar lines, therefore the alternate angle, the pair of alternate angle will be formed and they will be congruent. And if they are congruent, then the lines will be parallel. Then the lines are parallel. Okay, for that I have a figure over here. Now let's see. I have two parallel lines, line AB and line CD, and a transversal, that is EF, which cuts AB and CD on points P and Q respectively. And in the result we have angle 1 and angle 2 as a pair of alternate angles. Okay, but to prove that, what we have over here, we have to prove AB is parallel to CD, and to prove that we have done some construction over here. If AB and CD are not parallel, then being coplanar they will meet at a point R. If the two lines are not parallel, they will intersect at a point. Let's say that that point could be R, and PQR will be a triangle. And if it is true, what our figure could be like? Our figure could be like this, that PQR will be a triangle considered. Okay, so now let's see that which of the figure can be true to help us to prove AB is parallel to CD. Okay, so as we have said that the PQR will be a triangle, so let's consider that. In triangle PQR, we have that angle 1 is exterior angle and angle 2 is interior opposite angle to angle 1. Okay, now you can see that if triangle PQR, if PQR will be a triangle, therefore angle 1 will be an exterior angle and angle 2 will be interior opposite angle to angle 1. Okay, this is our construction. The reason is construction. And now we can see over here, if it will happen, we have proven in the previous theorem also that if such things happen, therefore angle 1, the exterior angle, will be greater than the interior opposite angle, and that is angle 2. Proven in previous theorem. Okay, so therefore if angle 1 will be greater than angle 2, but what do we have over here in figure 2? By considering figure 2, if angle PQR is a triangle, angle 1 will be an exterior angle, but what do we have over here? We have that angle 1 and angle 2 is congruent to each other, and if they are congruent to each other, If angle 1 and angle 2 are congruent to each other, it's given Therefore, angle 1 and angle 2 will be equals to each other. Now, if angle 1 and angle 2 is equal to each other, so now let's, if we before we move on, we say that this point is point 1 and this statement is statement 2. Now, if we compare these two statements, we can clearly say that statement 1 and 2 cannot be correct at same time, because if angle 1 will be greater to angle 2, so it cannot be equals to each other. Therefore, if they are equal to each other, so what will happen over here? If they are equal to each other, therefore the lines AB and line CD will be parallel. Lines AB and lines CD will be parallel to each other. Okay, let's take a review over here. What do we have over here? We have two parallel lines. A transversal is cutting over here. Line AB and line CD are two parallel lines, and transversal EF is cutting them on the point P and Q respectively. So there are the angles are formed, angle 1 and angle 2, which are pair of alternate angles. And for that to prove, we have a construction over here that if A, B and C, D are not parallel, let us consider this construction means that we have to consider over here that these given lines are not parallel. If we will consider that, so what will happen? We will try to prove that these lines are not parallel, and we know that this is not the reality. So what will happen? It will going to give us an absurd result and it won't count. So, and PQR will be a triangle. We'll see. In triangle PQR, angle 1 is exterior angle and angle 2 is interior opposite angles to angle 1. Okay, angle 1 is greater than angle 2 over here, as we have proven in previous theorem that exterior angle is angle 2. But what we have over here? We can see that in given we have angle 1 is congruent to angle 2. Therefore, our statement will be angle 1 is equals to angle 2. So statement 1 and statement 2 cannot be correct at same time. Therefore, angle line B will be parallel to line CD. Okay, so it will be QED, quad erat demonstrandum.